In this video, I'm going to show you how to do CPU profiling in Go in a quick way. So, profiling is something which you have to do to check and improve the performance of a program. And what a profiler usually does is it interrupts the program. It first runs the program, then it interrupts it time to time, and then it looks at the stack trace, and then based on that it gives us information about which function is getting called and how much time a particular function is taking. So using a profiler, it becomes easier to find out which one of your functions or which part of your code is responsible for slowing down your overall program, and then you will get the idea about where to improve your program. So in this video, I'm going to show you how to do profiling if you have a test or a benchmark already written for your program. So here I have a simple addition function, and I intend to profile this one. And for this function, I have written a corresponding benchmark. So benchmark, what it does is basically checks, it basically runs the function a lot of times, and then it gives information about the function, basically about memory allocation or how much time it takes, etc. So you can run a profiler on a benchmark function, and there are two steps. So the step one is you create the profiling binary with this command. So this, what this does is it basically disables the test and runs the profiler on the benchmark. So I've ran it, and as you can see, it has performed this many iterations and it says this much time per operation, and it creates this pprof file. The next step is actually to visualize by using go tool pprof command. And once you execute the command, there will be a terminal open, and if you write web here and press enter, then it shows you visually how your program executes. So in my case, it was a very simple function, which is why I'm only seeing one function here. If you had a large code base, then you will see lots of boxes here, and you will see which function is taking the longer time. So here you can see the times here. So total execution time is 330 millisecond, and you can see how it is divided among different nodes. And for a very complicated code base, you will see a lot more of these.